Hey everybody, this is Larry, this is me going with Q3 of the bi-weekly contest 82, minimum sum of squared differences. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one I feel a little bit sad about, and I always start with post-mortem, especially for contest problems, just because you can't see how I did the contest. I mean, you can, but not my thought process, so I'm thinking about it now. And I feel a little bit sad that I took half an hour and two wrong answers on this one because looking back at the tapes, I kind of got the idea almost immediately, but I was failing on this part. So there are two ways to do it. I'm going to explain my solution and then I'm going to do it upsolve because someone told me that I can do this another way. So we'll do the upsolving live and I'll talk about my thought process there, but I don't know how to do it the other way. I was just given like, hey, you can use this. So we'll see how that goes. So stay tuned for that or just skip ahead as you like. You're at home, you're watching. You can fast forward, I believe in you. Or even just, watch on 2x, whatever you need to do. Okay, so I think the first reduction should be okay. The first observation to realize is that you only care about the difference, right? So the square of the difference, obviously, but also just the difference. And one property you may notice is that if you make the difference smaller, you always, because this is just how n squared works, you always want to greedily decrease the biggest number. So if you decrease x for the biggest x, then you also decrease x squared maximally, right? And you could kind of prove it to yourself at home. Hopefully that made sense. The other thing is that notice in K1 and K2, there's a bit of symmetry around it, right? Meaning that you can, because you can modify nums1 or nums2, and because you only care about the difference, it is, it is the same to modify, like, yeah, if you're going to decrease the difference, then it doesn't matter if you do it from K1 or K2, and so you want to use all of the K. So yeah, so this is the reduction that I did initially, right? I basically take the delta, and this is what we said, we just take the difference away from between the two things, and then we can literally just add K. So the way that I did it is what I call simulation, but maybe turbo simulation, because basically what we have here is that now we have a difference array. So let's say we have some array that's, let's say the difference is, I don't know, 190. This is just the difference now, so I'm going to use one array to be clear. 80, I'm going to keep it sorted, reversed maybe, but yeah. So if I have this and say K is equal to, I don't know, like 80, right? Then the thing that I'm going to do in a greedy way, if you think about it one by one, is what we did, what we talked about, which is that, okay, after 1, there'll be 90, 99, 95, 90, 80, so forth, 98 after 2. So you greedy did it to do it this way, right? Dot, 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 until you get to 95. And then after 95, you go, okay, then we want to decrease it, 2 at a time. I mean, obviously there's some things about, some things about, like maybe if this K, that's one more K, you want to make it here and, you dedupe them, but otherwise it's roughly 2 at a time. So then that's basically the idea, right? Is that now we try to, so this would be how simulation work, literally 1K at a time. But of course, K is going to be 10 to the 9 or 2 times 10 to the 9 even, because you have K1 plus K2. So now what we want to do is by what I call turbo simulation, but just simulation optimized, if you will. And what I do now is go, okay, so the next event in this case, for example, would be 95. We're looking at 100. The next thing we want to add to is change it to 95. So then, this is just K is equal to 75 now, right? So that's the idea. Is then the next one we have, okay, 90, right? What would it take to get me to 90? Well, this is 5 times 2, so this is 10. So that means that we're going to get it to, 65, right? And then the next one is, there's a difference of 10, but between the 90 and the 80. So that means that we do it by 30, right? So K is equal to 30 at the end, or 35 maybe, sorry. And then you have 4 80s, right? And then now we have to do this 4 times. And then of course, if you do the math, and I'm doing this in my head, so I didn't have this prepared, but if you do count is equal to 4. 4 is over 30. What is it? 4 times 8 is 32. So then now we have 72, 72, 72, 72, and then k is equal to 3 or something like this, right? And then now we could finally end this by, removing 1, 1, 1, and then k is equal to 0. So that's typo. But that's basically the idea. And then after that is just implementation. So this one I definitely should have gotten this much quicker, but my implementation today is just really off, and that's why I've been really sad. And we'll go over why I got wrong answers in a second. So that's why I want to try the other one to see if I would have gotten the edge cases, but because I was thinking about it. But yeah, cool. And the way that I did it is by what I call using a stack, but you just basically do what we did, except for that instead of keeping track one number at a time, we have a second part of the tuple that includes the count, so that we can do multiple counts together is how we make this fast enough. And the code, it's kind of yucky. There's probably a quicker way of writing it, but basically we look at the last number. Excuse me, the last number that we process, we look at the difference, and then we do the maximal change, which is, because if we don't have enough k, then it doesn't matter, right? Also, if k is 0, 0, we just kind of put it on the stack and then we ignore. Of course, you can do merging here, but we don't even need to merge because we're just going to calculate the answer later anyway. So yeah, so then now after that, we subtracted from k because this is how much we used. And then now for each number, we minus change. And then this is just an edge case of, okay, if now the numbers are the same, then we can just, that means that, now we can merge it to the last number. So then this is delta sub I plus count plus 1. Otherwise, we remove the top of the stack because we all have it here, right? And then we just do a lot of case analysis. These cases, I'm not going to explain it, but this is just the exhaustive case of basically how to combine the last two elements or something like this, right? Where, okay, you combine the last two elements in a way that lets you do the visualization that we did before. I'm not going to go over the math. This is just really like thinking through every case. I think I did that during the contest, and that's why I was so slow. But and maybe there's a quicker way to write this, but and then at the very end we just do the answer, right? Each of them will have, let's call this C for slightly better. In this case, you can see that for each of these numbers, we have C count of these. So then we take the square and we take the count, and then we sum it up to be the total, and that's the answer. What is the complexity here, right? Well, this is just going to be linear time, linear space, except for the sorting, which is delta. So let me go over the two wrong answers that I have really quickly. One is that I forgot to subtract the last number. So if I have something like even just if I have something like this as one away, I forgot to subtract it, so I messed up. That's basically one wrong answer. And I think I was just too tired at the end, and then by the time I got to it, I was like, okay, I forgot. So the way that I did it, and you can see it, and of course you want to sort, I forgot to mention this, but you want to sort by delta so that we get the biggest numbers at the end, because this is part of the greedy that we talked about. So this is going to make it n log n. But yeah, in terms of complexity, let me just finish this part first. But yeah, so here the way that I did is by adding the number 0, so that now at the end it will try to match this, meaning that it'll try to convert this to 0, and that's how I fixed that issue. But my second answer is that I didn't update the n here, and because I didn't update the n here after adding 0, and that's why I have this update here, even though I have it here, right? Because I didn't update the n here, I just forgot to look at one of the numbers, and that's when it messed up. So that's two really silly mistakes, and that's how I did it. What is the complexity here, right? Well, first there's the sorting. So that basically it's going to be it. The sorting is n log n. The rest of this is linear time, and you could show yourself, because I call it a stack. Maybe it shouldn't be a stack, but it's a very vague stack. But each number we just do some if statements, right? So this is very straightforward. Everything's O of 1, so this is going to be linear time. So it's going to be dominated by the sort, and then space is O of n space for the delta array. and the stack, I suppose. So yeah, that's pretty much what I have for this explanation. I am going to go over, well, I'm going to try to upsolve it today, you know? So what I'm going to do, and I don't know quite the right way to do this, to be honest. So we will see if I know how to do it, and we'll do it live, and I'll do it with the full explanations and so forth. Yeah, and the way that someone told me that I can do this with binary search. I thought about this during the contest, to be honest, but I thought that, I mean, I saw the simulation solution, so I just opted for that one because I was more confident about it at the time. I was clearly a little bit wrong because it took me half an hour. So yeah, so let's see if I can do this with binary search. Yeah, because I was worried about not able to handle this quite correct, but because I think it is kind of tricky, because then you might have k left over or something. Yeah, I don't know that. Yeah, because if you have k left over, what happens, right? Then you can minus k. For k of those, you minus. Okay, maybe I can try that. I don't know if this is going to be right, like I said. So we'll see. So yeah, so now we're changing. Basically, my idea here now is that, oh, I should have kept the delta away. Whoops. We don't need the sorting now anymore. I don't think we even need that. I could be wrong. Maybe we'll think about that later. But then now, given this, the idea is that now we have a delta array of, say, maybe I'll do the other example that I have, something like this, right? Then the idea is, okay, and some k. The idea is that, okay, let's try to see if the maximum number is going to be, you know, I don't know, 70, right? If this is 70, then we know that it will use 30k here, 25k, and then you sum up the k to see how many you would use. And then the idea is to use the most k as possible, and then we'll do the math on it later. So that's what I'm going to try to do. Okay, so left is equal to 0, right is equal to max of delta. Yeah, right. Can we do 0? Yeah, we can do 0. So yeah. So here, this is binary search. And then now if good of mid, what does good mean, right? Okay. So good means that we can, the max number can be mid by using k constraints, right? K modifications, say. So okay, so if this is good, then we want to keep this number, but we want to try for something smaller. Okay, so that's basically the idea. And this is not good. We have to try bigger. No, wait, is this right? If this is good, we want to try a smaller number by using more k. If this is not good, then we have to try a bigger number because then it will use fewer k's. Okay, that is, I have to think about the off by 1 case. What if it's exactly mid? Okay, but I think this is okay, because if this is good, then yeah, we'll try a smaller number including this one. Okay, so the idea here is that this is actually going to be this good function, which is this question is going to be false all the way to true, right? And then the idea here is that, okay, and hopefully this makes sense, because you know, for if the max number that is 0, we will probably use up all the modifications. If not, then you know, yeah. And then the idea is that, okay, if this is good, meaning that let's say we're here, then what happens? Well, that means that this is a routed answer, and then we want to get rid of everything to the right. So that's why we kept everything to the left of the right, which makes this inclusive. And the way that I do it, I'm not going to go over binary search too hard on this explanation because it's already going to run long. But so definitely practice that. I'll have some, you know, explanations. But the idea is that, okay, this is, an inclusive bound, so I'm going to move the inclusive bound to include this bound, right? Because mid can be a possible answer. And then otherwise we have to do left. Yeah. Okay. Yeah. Okay. I'm happy with this. So let's write the good function now, right? And then now, what is the good function? Okay, so then now use this equal to 0 for x in delta. Use is increased by absolute value of x minus minus target. Yeah, because now you want to get it to target. Actually, that's not. This is wrong. This is if x is greater than target, then we do this. Yeah. Oops. Because we don't have to get it to target, we just have to get it over. If it's over, we trim it and use k, right? And then at the very end, we go if used is less than or equal to k, and that's basically it, right? And then now we know that outside the binary search, left is the max number that can be mid by using k modification. So then now we can simulate this once more. So maybe I have a k left thing. Right, so then k left we go okay, maybe I should put this function together. Okay, maybe I have a calc function, and then yeah, we return used, and then here we can return calc of target, right? And then now then we will so we calculate how many so left is the max number, so we calculate number of things that we used, and then k is equal minus this. Okay, so then now we can do it with one more iteration to get the answer, right? So now total is equal to 0. So how do we do it? For x in delta, if x is greater than left, which is the answer of course, then what happens? Yeah, x is equal to left. Yeah, okay. Yeah, if x is greater than left, x is equal to left. Total we added by x times x, except for we don't. So this is mostly right, except for we don't care about k left. Oops. So here we go, if x is equal to left and k left is greater than 0, we decrement and k left subtract by 1, and that should be good, maybe. Yeah, okay. I mean, at least it's good for that case, so let's give it a spin. Oh, yikes. Did I return the wrong thing? Maybe not. Let's see. Again, I'm solving this part live, so sorry if I'm pausing on the explanation because I'm still thinking through this problem, and as you can see, I just have this idea of binary search. I don't know how to solve it quite yet, and you can see that I could have some wrong answers here. So we'll take a look. Yeah. I click on it. Yep. Okay. So then here it thinks that k left is 32 is a lot. Oh wait, no. Wait, what? Left? Did I do this weirdly? Oh no, left is 0. And what's k? What's the input? Oh, 38. Okay, so this uses 32. So this. Huh, did I forget the case again? Okay. So everything should be 0, right? Why is this? Oh, wait. No, left is the answer, okay. Oh, I see, because okay. I mean, this is just a silly mistake. Okay. I am being really dumb. Because I basically was going to -1 is why. Yikes. Alright, let's try again. So maybe that was unavoidable, but maybe I could have gotten one. Like if it's faster, then yeah. So that's basically that. Okay, maybe I should have done it this way. I thought about it during the contest, but I thought that there'll be more edge cases on this way than the other way. But and I think I've done a similar problem before this way. But yeah, okay. So what's the complexity, right? Well, let's say t is equal to range of the numbers, which is 10 to the fifth, I think. Yeah, 10 to the fifth here, or 2 times 10 to the fifth. Then it's going. This one is going to iterate all of log t times iterations, and the good function. Of course, this is just linear, so this is going to be each iteration is O of n times. So this is going to be O of n log t time in total. And in terms of space, we use the delta array, so this is going to be O of n space. So yeah, so this is the binary search complexity versus the other one. So this is technically, I guess, depending on n and t, yeah, which one of them is faster. But yeah, but I think this one is actually a lot easier to write because you saw me write it. I actually thought about this case while I was writing it, but then I got confused and I forgot about it, I suppose. But yeah, cool. That's pretty much all I have with this one. So you saw me solve it twice. Hope this was good. That's all I have. You could watch me solve it live during the contest now. Also, maybe time limit exceeded. Okay. Whew, that was a hard one. People already get. That was a hard one. Okay. How many people got this one so far? 8 people. People always skipped ahead as well. Josh did in 6 minutes. Let's see. Okay. So this is going to be whatever. But I could do this in one line, I know. I see. Oh, this is the thing we have to do it. What is that algorithm that we used? The repeated heap one that we always forget. That I always forget anyway. I know how to do this. I just have to be careful about it. Okay, let's see. Basically, what do you want to do? X minus y, I think so, yeah. Why am I so bad at coding today? What am I doing, right? I think it's the other way around, right? This isn't right. It should be K. Instead of doing this funky thing. No, not yet. Basically, here we go. So the difference, we have K. Let's go. Right. That's how much we can change in theory. And let's just do it with stack. Okay. What am I doing? Okay. And now, wow, I'm really bad at this today. I knew what I wanted to do for so long, and I'm still like struggling. If now we want to combine the top of the stack. Okay, let's do it this way. Is that how I want to do it? Oh my. I can't believe I'm focused on the easy part of the puzzle, but I've been really bad at this math. I mean, this is just weird, but okay, fine. Okay, so let's see it. Okay, so now we spend change times count. We also remove, that means that last the chain. And then what happens? Then it is what? Let's say the change is 20. Say there's 2 and there's 1, right? So then this is last and last plus 1. Don't know which way it should be. Well, I guess this way is fine. What am I doing? Okay. Wow, I'm really bad today. Okay, focus, focus, focus. You got this. Okay. Change count is the number of count, so this should be roughly right, but this is probably not actually right though. Okay, it's going to use 0 then. No, that's not right. It's every number. Okay, that means that every number here minus change, and then with k has left. Okay, I see. This is also wrong, maybe because we have k left. No, that's fine. Yeah, okay. So that means that's last plus 1. That has. Yeah. We have k of them, then k of them will be here. Okay. Did I mess up? I definitely did, but I have 3 4s. Okay, so this is 0. And I did some crazy stuff. So diff is 0, 0, this changes 0, this is 0, so k is non-zero. Okay. So this is true, so we pop and then plus 1. Okay. And we do it again, maybe. 1, 4, 2, 4, 3. Okay, and then now we see the 3, the 3. I see. So that means that we have K left. Get 4, 3. We have 0, so this is going to be 0, so this is going to go to here with a 4, 3. Four, 3, K is equal to 2. What does that mean? It means that we append. Now we want yeah, okay. K is equal to 2. I think I'm missing some now. Right, because we have to add the one number that we put in, which is the 3. Okay. I don't even know if this is right. This is going to be so long. Otherwise, if this is not the case, then we do this, and then we would. Okay, I mean, this part is right, but I feel like I'm really bad at this math. But okay, I have to do a little bit better than that, I think. Whoops. Is that right? So 3, 1, 2, 3. Okay, that looks right. Though the stack is printed in the wrong way, which is actually really bad. How did that happen? 100, 98, 98, and then 97. Oh, wait, what? Okay, I guess this is right, but why is this reversed from what I expected? Also, that's wrong, I think, because we have 50 times 2. Start 100 and then. Well, this was already wrong. Oh, I know that's not true. With this, and then this goes to this, which is very wrong. Okay. and then I do ray and okay, maybe that is right. Oh, now it is right, maybe. This one's wrong too. Yeah, there's no way this is just... Okay, good thing we're catching it, but it's still very sad. So with 4, you have... With 4... Happens around. That's why we test these. Okay, so this is 4. Okay, so now this move to 2. Right. The next one we're gonna oh. Wait, what? And k is less than 0. In these cases, it doesn't matter that much whether we combine them, so should be okay. Are you confident now? I don't know. Alright, let's go. Let's go. I don't put anything extra. Come on, please. Pretty, please. Oh, man. Oh, I think I didn't do the case where I forgot about this one case. I didn't know this, but that was dumb of me. Yeah, okay. I was thinking about this case, but I got it wrong anyway. Okay, well, did so much testing and still wrong, so that's we're actually way sad. Why is that wrong? What if 354? What is that? Put here 0. Okay, so why do I skip every other number? Oh man, do I do this? Oh, did I pop something by accident? Maybe. I don't get it. Tell me why. Yeah, why do I not go? Huh? Did I mess up? Why? Oh, why is it skipping ahead? Am I missing something? So it starts here with the, okay, I mean we have 17, but we don't do 15 for some reason. Wait, why do we start at, oh, because I added a number and then I sorted, so this should be, oh man. So right now, 579. Yup. Okay. Wow, I am a bundle of stupid today. How do we move this one to? 579 is the right answer, okay. I mean, that's the most frustrating part, is when you have it, but it's just like a silly mistake, right? Like if I'm wrong, then I'm wrong, but come on, okay. That was a lot of silly mistakes. Yeah, give me some support, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problems. I'll see you later. Stay good, stay healthy, and good mental health. Take care. Bye bye.